And if it finds a particle which is within 6 units of itself, it will then jump and try to distribute itself to another location. And this actually ties in with a parameter that you have down here just below uniqueness. It's called attempts maximum. And that basically determines how many attempts per particle each particle has to distribute itself before it gives up. Now, in this case, you can see we've got 100 attempts here, so it's quite a lot. Positioning only happens once, so you can basically go with this. It's a bit of a luxury, but it doesn't really slow down your particle system that much. So each particle will try to position itself 100 times before it gives up. And on each occasion, it'll say, am I more than 6 units away from any particle around me? If it says yes, it won't do any more. It'll just position itself. If it says, you know, I'm not, it will keep on going until it reaches 100. Now, another option that actually ties in with this attempts max is delete particles if location is invalid. And that works, as you can imagine, in the way it sounds, which is if it reaches 100 attempts and it can't find a valid location, the particle will actually kill itself. It's effectively deleted from the scene. It's like a delete operator. So that can be quite useful when you want to distribute your particles evenly over a surface, but you don't know quite how many particles it's actually going to take to do that. So what you can do is you can actually throw a lot of particles at a surface, and then you can say any particles that can't distribute themselves within my rule, you kill yourself. So the particle basically disappears from the system. So you can see that separation, distinct points only, and attempts max, and delete particles if the location is invalid. All of these operations all work together. Okay, so as you can see, that's quite a useful feature, being able to limit where the particles are on the surface, only have them at at distinct points, also to give them a separation value. All these are very useful, great when used in conjunction with the other options in this particular operator. And the last parameter, as per usual, is uniqueness. Again, this is used to determine the random position of particles, and you can use the new value, or you can enter a value here if you want to synchronize it with another operator to get an exactly the same result, or you can randomize it to completely give yourself a completely unique look for each operator. So there you go, that's position object, and as I said at the beginning of this particular section, it's a very key operator, and it allows you a lot of flexibility in the way that you assign particles to meshes. You can see you can have your particles stick to a mesh as it's animated. You can distribute your particles using bitmaps. You can actually paint on where you want your particles to appear. You can actually control exactly what the distribution type is like, if it's completely random, or whether we're using distinct points only, or whether we're using some sort of separation value. So there are a lot of options there, and this particular operator, it's well worth loading up this example file and giving it a try out and see what you can do with it. And it's also worth getting used to in general, because it's something that you'll probably use time and time again when you're using particle flow. Okay, let's move on to the next operator, which is the rotation operator.